All right, welcome everyone to Nand2Tetris. This is week 10, is that right?
Is it?
Oh,
10?
that's what it says in the bottom right corner of my screen. It says that this is week 10, so yes, it's week 10.
All right.
I probably looked at the calendar when I was making the event, so hopefully that's right.
Week 10 of
Um,
the book, it's like week 30, real time.
yeah, that's true. It's pretty nice that we're not actually taking this course during college because uh, obviously we would have been far behind. Um, So luckily we have lots of time for any of you who are following along that are taking it in a college course. I noticed recently with fall beginning, we've had a big uptick in how many people are watching videos and things like that. So if you are, then good luck. We hope that these videos are somewhat useful to you. Um, and just be aware, during the videos, we try to make a point of pointing out which labs were harder and easier. Obviously, that comes from our experience where we both have a lot of experience writing web applications. So some things are naturally going to be easier or harder for us than they might be for you. But anyway, I hope it's helpful, and I hope we can steer you away from at least some of the major pitfalls that we ran into. So Dan, do you want to start off with anything that you found interesting, kind of in the from the intellectual side of the project this week or the chapter?
Yeah, actually, I'd probably say from like the project point of view, this is my favorite one so far, which is interesting because as a confession, I feel like mine wasn't 100% successful in that while I can compile the files successfully, when I looked at the output, the generated output isn't exactly the same as what they specified. So that's kind of a bummer. On the other hand, I kind of feel like the output I'm producing loses less information than the desired output, so I'm kind of happy about that. I mean, I spent probably more time than I should have trying to like get it to like match, but it made the code worse, and it just made me feel worse about it. And I've been having a ton of fun with it up to then, so I'm like, forget it. I'm just gonna I'll throw in the towel and say it wasn't quite like to spec, but I'll live with it because I think the differences won't be too hard to work through in the next exercise. But it was a blast. I felt like it really like leveled up my closure to the next level. I guess that's what leveled up means. So I apologize for the redundant statement there. But anyway, yeah, I felt like I got a lot better with closure. I actually started writing some tests this time, not like extensive, but enough that I was actually using it to help drive some of the implementation. So yeah, all in all, I felt really good about it. I mean, I could talk about show some code and talk about it if we like. I don't know if I want to bounce over to you and get your general thoughts first, though, before we dive into mine. Either way is fine, so just let me know.
Well, I think I'm going to have you, if that's okay, show your code last this week because I took a sneak peek, and
Oh,
I think it is more interesting than my implementation. I'm really curious to see. I know last time I took a peek, you weren't fully operational yet, but the direction you're going with it was really interesting to me. And so I'll do my general thoughts, show some code, and then I'd like to turn it over to you at the end with plenty of time so that you can kind of walk through the thought process that led you into the code that you ended up writing.
cool.
So
I'm very excited to hear about the Elixir stuff, so that's exciting.
yeah, so the last couple of projects where we needed to write something on our own language, I chose Ruby because I'm really familiar with it. And I've just been experimenting quite a bit recently with other languages, just trying to broaden my thinking about programming in general. And a lot of what I've been hearing about pattern matching languages made me think, oh, that would be a great way to write a parser or a tokenizer. And so I figured that that would be hopefully a good match. And so I tried to write mine in Elixir this week. And my experience was really, really positive. Elixir was, I feel like it was a pretty natural fit for the project. I had like the tools for how you write Elixir and how you run Elixir, and the kinds of error messages it gives you were really, really helpful so that when I had a problem, it was pretty easy to pinpoint exactly where I had gone wrong. I do think, so I'll mention when I was looking at your code, like I said, I was really impressed with the structure of your code. I think, and as I look forward to next week, I definitely did notice that the intermediate form that they want us to create as part of this week's project really is incomplete in terms of how much parsing we really want to do in order to generate machine code, or the VM code, I should say. And so my approach to this project, like many of the other ones, was that the first thing I did is write like a little integration shell script, which just basically runs through all the Jack files that it can find in project 10 directory, passes them to my tokenizer and lexical analyzer, and then pulls back the XML and uses the file comparison utility to just say, like, hey, is it the exact same? And because I started from that point of view, rather than starting from the point of view of reading the chapter and really understanding the spec, I think it pushed me in a certain direction in terms of how my implementation works, and it got it so that my XML matches their XML exactly. But that being said, when I started looking forward to next week, I did realize some of the things you're talking about, where, I mean, the XML that you need to create in order to pass off Project 10 really isn't exactly the format you're going to want that data to be in order to start generating VM code. So it makes sense to me why they broke up Project 10 and 11 the way they did. I think if you took on any more than what was already in Project 10, it would be very hard to get it implemented in a timely manner. But at the same time, it's not a natural place to break the project, because really you don't want to represent your parsing of a Jack file in terms of XML. Like, that doesn't. It just is it's a convenient way to be able to compare and not care about things like white space or indentation. So I can, like, again, I can understand their reasoning for it, but people going into this project should kind of realize that, and maybe check with their teachers or TAs or whatever to see how much do they care about it matching one-to-one versus how much do they care about it just understanding the semantics of what's happening in the Jack language. So I'll dive in just really quick and kind of show what was going on with my code this week. Can you see that all right?
Yeah, sure can.
All right, so I'm never happy with my editor, and I'm back to Vim again this week. I don't remember if I was last week or not, but anyway, so this is my little shell script. It's actually running Ruby, because it's just easy to kind of bust out stuff like this. So I basically figure out the root of the project. So this is like the project 10 directory. And then I basically run through, let's see, my scripting stuff actually starts down here. So first I am just worrying about the tokenizing stuff. So I use a little Ruby trick to say, look inside my root directory and look for anything that looks like */*t.xml, and grab all those, figure out what the corresponding Jack file would be called, and then tokenize that Jack file and give me back a temporary file, and then compare my temporary file with the file that was already in the project. And so it just does all my tokenizer tests. And so when I first started, I just wrote this much, just like this much of my file, and then the corresponding little helper methods up here. So like the tokenize just basically says, oh, cd into my project path where I wrote my tokenizer, and invoke my tokenizer with the given Jack file, and then output it to the temporary files path. And so I kind of have these helper methods, but I basically just had this much, and that was just kind of enough for me to see, oh, my comparisons are failing, let me start working. And so like I said, it's a very pragmatic approach. Like, I'm really just trying to get all the comparisons to match, and I'm not really worrying too much about, am I really understanding the semantics of the language? But that ended up having pros and cons, right? Like, if I was getting graded on this, it would be an obvious A because everything matches 100%. But on the other hand, it's less complete, I think, for Project 11. So as far as the actual implementation, I called it JC for Jack compiler, and basically my entry point for my tokenizer is this little what are called mix tasks in Elixir. It's kind of the same idea as a rake task for Ruby, or a make file for make stuff, C and other programming languages. But basically, I just import my own library, and this run function gets called and just passes me my command line arguments. And then I just run through all those arguments and say, map over those, calling the file.read method. So that just however many files got passed as arguments to this command line, I'll just run through and read those all into strings, or what Elixir calls binaries. And then I join those all together with a new line. This is not actually really a good idea, but that's fine. And then I just call my tokenize method, and I then have this little toXML helper. And the toXML just basically wraps my whole output in these tokens, opening and closing XML tags. And then I run through all my tokens, and I enum over them, asking it to turn my token into an XML tag, which is just this little helper right here. You can see all it does is that I turn my type into a string, and I make that an opening tag, and then I escape my value. And this is the pattern matching stuff in Elixir that I found really helpful this week. So basically, I can just write the escape method 4 different ways and say, hey, I know that if I'm trying to escape a string that just contains an ampersand, I actually need to return like an escape ampersand, or an escape less than or escape greater than. And then if what was passed to it is anything other than those, then just return that thing itself. And Elixir basically will always try to run these functions in the order you define them. So I always know that this is the first one that'll be tried, and then the second one and third one. But it optimizes very heavily for the matching of those things, so that the tokenization ends up, like calling this method with a string, ends up running really, really fast. So that was pretty cool. And the other nice thing about that is, if it tries to run all these different things and it wasn't able to match any of them, you get an error that says, I tried to match this thing, and I couldn't find a method definition or a function definition that matches this. And so you can see exactly what the string was that didn't match, and then look at your definitions and go, oh, okay, it was because I didn't have a case that would match this thing. So that was really helpful. And then my tokenizer just basically looks like, let's see, lib chat tokenizer. Did you have a question?
No, I'm just, that's some serious heavy-duty industrial strength pattern matching going on there.
Yeah. So the tokenizer has a couple of cases, like the comments are actually really kind of the hardest cases. I happen to have a lot of experience with regex. So what I did is just say, hey, if you run into something that looks like a comment, either this is like, oh, I need to comment out from here to the end of the line, and I do that with a regular expression right here. And then if I find the multi-line comment token, then I do another regular expression to say match everything up until you find like a star and a closing slash sort of pattern. And anyway, what I basically end up doing in both those cases is just saying match all that stuff and then throw it away. I actually don't care about it, and instead just find me the rest of the string after that match completed, and I just call the tokenize method again with whatever was left without adding anything to my list of tokens. And so I kind of let those 2 cases take priority so that I can always just throw away tokens really fast. And my next priority is getting rid of white space. So I say if anything looks like a space, a new line, the weird Windows new line, or a tab, then I just do the same thing. I just throw away that part of the that beginning part of the string. So what this match here does is say, look for if my string starts with this thing and then contains something else, and in this case it just says anything else. So what ends up happening is I just recursively call tokenize with the rest of the string after the match, and then and once I've gotten rid of all comments and all white space, the only things that are left are basically keywords, symbols, and then finally some identifier stuff. So you can see all my keywords here. I just say, hey, if you found a string, if the rest of what's left in the string looks like class and something else, then my tokens are actually just these little tuples, right? So it's sort of like an array that just has two elements. And I say this is a keyword and its value is class, or a keyword and its value is constructor. And then I just do the same thing with symbols. I say, oh, if the next thing in the string is a left parenthesis, then add a symbol, or add a token called symbol with a value of open parenthesis, and then recursively call tokenize on the rest of the string. So it's kind of all turtles on the way down. And then the only other place that it got slightly weird, maybe I could have done better pattern matching to actually solve this, but there's a few cases where it's like, oh, an identifier is only valid if it starts with a lower case or uppercase letter or an underscore, but then then the successive characters can be uppercase, lowercase, underscore, or a digit. And so, like, I ended up just finding that easier to write as another regular expression. Constant integer constants and string constants, I kind of did the same thing. I just said, match until the next closing, whatchamacallit, double quote here. And then finally, at the very end of all this, if I haven't matched anything, then I just raise a specific error. And again, this was super helpful. This was kind of like the first thing I implemented was this case right here, where I basically said, I don't know how to match the rest of this, and I just explode so that my tokenizer would just fail rather than producing invalid input. And that made it really easy for me to just be like, okay, try to run the tests. Oh, my tokenizer is returning something. My tokenizer exploded and said it couldn't match class. That was like the next thing in the string. Oh, okay, I know exactly what I need to implement next. And so it made it really fast, kind of iterative cycle to just do one more thing, one more thing. So then my compiler ended up getting split up into a few different files. We'll just look at kind of one to get an idea of what ended up happening. I think I called it parser.ex, yeah. So I have this initial parse function, and what it does is it calls, right off the bat, what I kind of wanted to do is say, I want all of my function names to be like the name of the semantic, kind of like the semantic part of the grammar that I'm trying to parse right now. So, so for a class always has to start with a keyword with a value of class, an identifier with an arbitrary value, and then the opening curly brace symbol. And so what I can do here is say, since what I'm taking in is a list of tokens, I can say, try to match a function called class that starts with these three symbols and then has some other stuff in it. This is the matching, just whatever else is in this list. I don't care yet. And then what happens is I say, okay, great. Now I know that what my parse tree looks like so far is this array of these three symbols. And now I can I know that the next thing that I'm expecting is a class variable declaration, which is really, my naming kind of got better as I got further into this, but really this should have been something like class var dex or optional class var declarations or something like that, right? Something a little more descriptive to say that, like, oh, I can match 0 or more of these things. But basically the way you do that is by saying, like, oh, if the very next thing is a keyword, then, and the keyword is either static or field, then that's a class variable declaration, and I should be able to grab that and then parse out a type next, an identifier list next, and then put all those children that I've kind of been accumulating inside of a nested structure called the class var dec, and then recursively call myself. And if I don't match a keyword that is static or field, then I just give up and I return only as much as I have so far. So this is kind of just a nice way to break it down, and all the rest of my parsing ends up following the same pattern. Once you kind of get into a pattern, there's still a lot of work to do. I figured out this pattern probably about 4 hours into the project, and was thinking like, oh, smooth sailing, I'll wait until next Tuesday to finish this, and then totally realized that there's still a lot, like, even though I knew the pattern of what I was doing, it's still just a lot of work to implement all the different cases and make sure they're all. But one thing that I thought was pretty cool after all this, so just show real quick. You can run the integration test. And I wasn't sure how long it would take to like do the tokenization and do the parsing. So you can see here as it's running, and it's doing all these text comparisons against these kind of canonical XML files that were given to us at the beginning of the project, that it's taking about a half a second for each one. And I thought, oh, that's okay, you know, that's not super slow or super fast. But what's interesting is when I dug into it more, the Elixir VM, when it starts, so it's really starting an Erlang VM and then bootstrapping the knowledge of how to like run Elixir code sort of on top of that. Sort of, that's not totally true, but that's a simplification. In any case, all that takes almost a half a second. So I was like, well, how fast is this thing then? And so I wrote a little benchmark task, which I'll just show real quick, that basically just says, hey, take the square.jack file and tokenize and parse it. So tokenize and parse just says, take a string, pipe it into my tokenize method, which got imported from my tokenizer, and then pipe that into my parse method, which comes from my parser. And I just run that inside this little benchmark utility. Mm-hmm. And if you run this mix benchmark, I think is how I invoke this thing, it will actually just run it as many times as it can for a second, and then does some calculations. And what's crazy to me is it takes just over 2,000 microseconds per parsing of that file. That's like, so that's 2 milliseconds. That seems crazy, crazy fast. That, you know, that means that I could parse 511 classes in a second. So Elixir ended up being a lot faster than I thought, which was pretty cool.
Yeah, that's way cool.
So yeah, so that's, I took too long explaining my code, but anyway, I had a lot of fun. Elixir was, I felt like a really good match for the project. It was really easy when something wasn't matching, when my code encountered a next token that it didn't know how to match it against something, it would explode with an error message that said like, invalid argument match this thing. And I could see that the very next part of my list of tokens was like, keyword class. And I was like, oh, great.
Okay. Hope I didn't disconnect. Sorry, I don't know. I was just checking to see if I was still connected to the internet. I think so.
Oh, there you go.
Ah, all right. We're back?
Yep. Sorry, had I cut out during part of that?
Yeah. I thought it might have been, yeah. Anyway, you did. So I'm not sure what I missed.
Oh. Well, anyway, I was just wrapping up by saying I thought Elixir did end up being a pretty good match. I think either Erlang or Elixir, because of the pattern matching that's kind of built into the language, would make a good fit for this project. But I don't know. It worked for me. It took, I think, in total probably maybe 12, maybe 16 hours of work if I totaled it all up across many nights of only being able to work for an hour at a time because of kids. So take it for what it's worth. But anyway, I think I would definitely, as you're working on your parser, the main things that I think caught me up were just to be very intentional about saying, oh, I can have 0 or more of these things, or I can have 1 or more of these things, or I can only have exactly 1 of these things. And if you always know that the next thing you're going to parse is 1 of those 3, then you can usually come up with a pretty good pattern that lets you kind of rinse and repeat to do those.
That's awesome. They look really cool. I thought I saw some like tests there too. What was the testing situation like on Elixir? That always seemed pretty cool, like parallel testing is built into it.
Yeah, I'll just show one real quick here. So I can run my test suite, and right now I have 40 tests, and you can see it recompiles and runs all my tests, and that took about 1.2 seconds, so not bad. And my tests basically look like the tokenizer test, for instance. I basically just say, test some really basic tokenization. This is kind of like my first test that I wrote and tried to run. So I just said, let's just assume I had a string with this much jack in it. And then I know that what I expect to get out is this list of tokens where the tokens are the order keyword, if, symbol, open parenthesis, etc., right? And then I can just say assert tokenize that. If I tokenize that jack string, it should equal my list of tokens that I've given you, right? And all of my other tokenizer tests are along these same lines, right? Like I'm adding in other special cases of saying, oh, if I add in this giant multi-line comment, I should actually still end up with the same list of tokens. And so I added a little Vim shortcut to just say run all my tests. I never actually ended up writing a Vim shortcut to run a specific test because 1 second is fast enough. And actually, when I'm not on Google Hangouts, this only takes a little under half a second to run all my tests. And so it was fast enough that I just never bothered to need to run just one test. But anyway, so this is kind of where I started from. And but you can see, let's just all intentionally break one of these tests here real quick. And if I rerun the tests, we'll be able to see what the error messages look like. And so you can see, hey, assertion failed. You told me that when I tokenize this jack string, it should equal the list of tokens. The left-hand side of that expression ended up looking like this, and the right-hand side ended up looking like that. And so then I can look through this really quick and go, oh, what's missing is this stuff down here, right? The left-hand side gave me an additional symbol and another symbol, and those weren't in my expected list, which is only because I just intentionally broke this test, right? So, so the matching stuff that's kind of built in throughout the whole language does make those kinds of error messages super helpful, and they really point you to where you need to go next.
Very cool. Very cool.
So, do you want to jump into the closure?
Yeah, I guess let's do it. If I can, there we go. Screen share. All right, can we see all this?
Yeah, maybe just bump up the font just a little bit.
All right. How's that?
Looks good.
Can you see the whole thing? Can you see my cursor?
Yeah, I see the cursor.
All right, the Google Hangouts thing was floating in a weird place, so I was wondering if that was the cutoff. All right.
Yeah.
Okay, oops, that's kind of a... All right, so yes, this is kind of, I guess, there's some similar breakups to how you had it here. I guess if we look at the core file, I can kind of see that this is pretty simple. There's a tokenizer, a lexical analyzer, and then an XML formatter, and it kind of just pipes it through to various things, one step at a time. Tokenize it, and then analyze it, and then print it, and format the thing. So we'll take a look at the tokenizer. So one of my goals with this, like a lot of when I've fooled around with compilers in the past, and I've never done anything serious, but most of the time it's just been like regular expression type stuff, reading entire lines or files in at a time, and then regexing through it. And this time, for whatever reason, I'm like, no, I want to read it in one character at a time. So then we can use something like a character sequence, a character seq that just pulls in one character at a time from this file. So if it ever hits like a bad character, it could just blow up at that point before it reads anything else in the file. So that was fun to do. I mean, I don't know that it was the right way to do it, but it was fun. And what ends up working out is it kind of like, so I guess you could say I basically re-implemented regular expressions, because what I ended up building was more or less a state machine where the tokenizer starts off in a start state, and then based on what token and what character it reads next, it just goes ahead and like shifts from state to state and keeps track of, do I need to be accumulating this token, or can I just throw it away, or do I need to finish the result? Have I got like a token? So once again, the commenting was kind of like was probably the hardest part for this one too, because I had to like, all right, if I see a slash, then I know I'm getting, then maybe I'm starting a comment, so I need to like keep track of that state. But if we go down to that state, then let's see if I can find it where we. And if I see another slash after that, well, that's a new line comment, and I can go into that state, which is basically I just ignore everything until I see a new line. If I see an asterisk, well, then I'm in a multi-line comment, and I need to shift into that state. Or otherwise, if I just saw a single slash, then what I wound up with was a actual slash symbol. So I need to like add that and then shift back to the start state. So I'm not going to go into like every state, but that was that was interesting. It just ended up being a state machine that gives me tokens. And my original pass at this was just like mapping all this into like a vector of tokens, more or less. And then I thought, well, if I'm doing this like as a sequence of characters, what I would really like to do is return a sequence, like a lazy sequence of tokens. So I sort of did a little bit of refactoring to do that. So it will just pop off a token at a time, so that when the tokenizer is, or when the lexical analyzer is passing over it, it will blow up and only read so far into the token sequence as it needs to before it explodes. So the overarching thing here, I think, is that if I did it correctly, is that as soon as it like reads a character, since everything's being read lazily, as soon as it gets to a bad character that leads to a bad token, it just doesn't read anymore and blows up. So
yeah, so I was just going to jump in and ask. So that basically means that like if you had a syntax error in your file, you only would have read the first X number of bytes of that file, like enough just to get far enough to know, oh hey, this is something wrong. So like if I tried to call this on like a Ruby file, it would probably read like through the word class and then maybe the name of my class, but then when it didn't see a curly brace, it would probably just fail at that point and would not have even read the rest of the file. Is that right?
Yeah, at least in theory, that's what it should be doing. If I did everything right, that's exactly how it should do it.
Very interesting. Yeah, the lazy streams is a really interesting way of handling things. I know it's supported in Elixir, but I didn't bite off that particular piece of learning.
Yeah, I just know that like a lot of the theoretical underpinnings of Clojure specifically are these idea of seeks, these seekable or sequence things. So I felt like I was taking a tiny step further into Clojure Zen by thinking, oh, I could do this as a token sequence rather than just my normal mapping things and dealing with a mapped collection.
Right.
So I did think about doing that for the parse tree, the AST I generate with the lexical analyzer, but I didn't get that far. So yes, so that's why I spent the whole first weekend working on pretty much the tokenizer stuff and didn't get really anywhere into the lexical analyzer. So what I wanted to do, as soon as I saw like the grammar, was like, what I want to really do is just define the entire grammar in like as a data structure, and then like kind of define it in terms of other elements, and just be able to like process tokens through this thing. So obviously, like with the symbols here, I don't know if it's obvious, but the symbols, Clojure keywords, I guess they are the non-terminals, and then everything maps to a vector of various either terminals, the strings, constants are terminals, and of course non-terminals. We'll get to the anything in a minute, but the sets, the little hash curly brace thing here represents a set of values. So that could be kind of the OR. That was the OR construct. It could be either of these two things. Trying to think if there are any other data structures I used here. I tried to use as many Clojure primitives as I could, because why not?
So, sorry, can I jump in and ask a few questions?
Absolutely.
So, first, I just want to say, when like the first, so I waited until I was completely done with mine before I went and peeked at yours. And when I saw this file, I was like, oh my gosh, I am such a noob programmer, because this is like, it's so beautiful to represent the grammar of the language as a data structure. And it made me think of, like, I know that there's those C projects out there, right, like RACC, R-A-C-C, where you basically do this. You just hand RACC, like, here's my grammar as a data structure of some kind. I don't know. I think you represent it as XML or something. Mm-hmm. And then it will write a C program for you that, like, it'll write it and compile a C program for you, which is like, here's your parser, and which is so awesome. And that's exactly what this looked like to me. You were doing is kind of like, okay, I'm going to start by defining my grammar as data, and then write like a general purpose parser or analyzer, I guess I should say, that could take any grammar and any stream of tokens and parse it, which is just like, it's just crazy to me that you were able to make this work. So super kudos, but I was curious, obviously in this case you call like the maybe function a few places and the any function, and that looked like sort of the analog of what I was doing. I was doing it like re-implementing it in several places in my code, but it looks like that's the concept of saying this may occur 0 or more times, or it may occur 0 or 1 time. Is that basically what it is?
That's exactly what it is. So I kind of wanted, the original names were like 0 or 1 or 0 or more, but those are too long. I like wanted it shorter. So just any is like 0 or more, and maybe is 0 or 1. So those are basically just high-level functions. What they do, I'll pop up to their definitions. You can see any is defined right here. That actually returns a function that expects the grammar to be passed into it, the remaining tokens, and the current abstract syntax tree. And basically just sets up some stuff to process that. So it's basically replacing itself with a function. Then if we get down to the process token portion, process construct. I've started running out of good names. How can I not find it? There we go.
It's process something.
Yeah, process construct. So if it's like if it's a function, it basically just ends up calling it and passing like the current grammar and tokens and AST, and then it knows how to return that so it can continue processing it.
Oh my gosh! So sorry, I'm like interrupting your time, but this is so amazing. This is like, I think you have arrived at Clojure Zen at this point, because this is why people love Lisps, right? Is that you're creating, like, you're not only representing the grammar as a data, but actually like as a functional composition almost, right? Like, this is nuts that this actually works. I'm just super, like, I actually would want to go back and rewrite my parser now to try to do this, because this is super cool.
You're too kind, but yeah, thank you. It was a lot of fun. Like, this is exactly like, it was nice that it worked out, but, well, not exactly. We'll get into that like at the end of the story here. But it worked out pretty well. Like, it feels a little procedural here because it's switching off a bunch of stuff. I probably could have leveraged actually the multi-methods, Clojure's multi-methods, to break these out into little smaller pieces. If I'd kept working, I probably would have. This is kind of the outer function here, is the process constructs that basically starts off with with one of these. Let's see, get back to the grammar definition here. Oh, crap, yeah. So the outer one expects a vector of tokens, and then the process construct itself gets each one of these in turn and knows how to process each little token. So it knows how to process a string, knows how to process a keyword, or anything, these functions essentially. The other things, I guess, that end up being interesting are just the literals. When it gets down to the final, these things here are also functions that get called and just return their corresponding value. So I think that's probably about it, but you can just kind of see here. I mean, the interesting thing, I thought, one of the funner parts was like the set actually goes where it goes through and actually tries to continue processing each token in there, and then just throws an exception if it can't continue processing it, and accepts the first one that works, and then you powers that as the result. So that's kind of fun. Yeah, so this is kind of the entry point to this the lexical analyzer. You just pass in a token seek here, and then it kind of seeds it with the outer, the initial non-terminal and the initial AST, and keeps processing it that way. I think that's pretty much it. The XML formatter is kind of unfinished because when I started noticing that it was like different in structural ways from the actual output, I'm like, oh wait, I've got more systemic problems than mere formatting. So I sort of like abandoned that, but we can take a quick look at it because there's not much. Actually, what I was hoping to play with there was, why is this not? There we go. Yeah, it's not doing a whole lot, but since it's just a data structure, like a list, essentially, it's really easy to walk down it and do it recursively. I don't think this is the prettiest code because it doesn't have, all these name elements could be factored out. In fact, I remember going to bed one night and thinking, as I was falling asleep, what I could do to clean this up, but then I never got around to do it. Oh man, so this is sort of bad. But my initial hope was like, oh, this it's XML, and Clojure's running on the JVM, and there's got to be great XML libraries for Java. I'll just punt to one of those. And like, no. I was even on Stack Overflow. It's like, here's how you could do this in Java. I'm like, no, I wanted to play with the interop. I know I could write it myself if I had to. I wanted to do the interop stuff. But anyway, no such luck, even though it's Java. So it's just kind of some crappy XML munging. But I'll do like a quick a demonstration of the problem I was talking about, like why I realized I was kind of screwed and would never work. I think is this it right here? No, I need to like rebuild this thing real quick. Do it because I was on a bad branch. Regenerate it. Yeah, here we go. So this is like how mine parses one of these files. You'll notice that identifier is wrapped in a more specific thing where it says, oh, this is a class name identifier. But if we look at the output from the real thing, it's just a flat identifier. Which when I saw that, I was like super bummed. I'm like, well, wait, my way is like, now I know. But what was really crappy was I think is it the term? I think maybe parameter. No, parameter list is there. There was something. Statements was a little. I guess statements is okay. I think mine's wrapped. Each statement's actually wrapped in a statement block, rather than just being like a straight statement. So, and that's just because the way mine processes like non-terminal to just recursively at each step says, okay, here I am, grab my children and dump them inside me, type situation. So I really felt like torn. I'm like, well, I could make it work their way, but I don't like it very much. I think it came down to the when you're looking at maybe a function call. Maybe that's what it's real. Let's see if I can find a do statement in here. All right, like a subroutine call, subroutine name. Let's see if what that looks like over the other one. Whoops, wrong way. Do statement. Yeah, see this. I just do not like it as much. I like this being like a subroutine call thing here, and not losing that whole subroutine call deal. Anyway, so I felt bad because I sort of preferred mine. I'm like, but I spent hours trying to like munge it and make it like work, and it was getting crappy, and like I had not considered that architecture, and I was totally falling down when I tried to implement it. But oh well, it was still a ton of fun.
Yeah. So I'll say, so like I said, this is where I think it's really interesting that you and I took very different approaches, where it seems like I mean, correct me if I'm wrong, but it seems like you basically started by saying, I want to really understand the grammar. And you went from the book side of it, like, let's understand the grammar of the language really well and implement a parser, and you kind of went from that theoretical purity standpoint and then wrote an amazing parser. And then I was like the pragmatic approach, like, hey, what I expect to get out of this week is something that generates XML, which is totally equivalent to their XML. And as a result, there was a lot of places, like, I didn't really think about the grammar all that much as I was implementing it, to be honest. I like looked at the grammar page, kind of that listing that was like, oh, you have these terminals and these non-terminals, and I was like, okay, yeah, I got it, and I just started going. And because I had like this really nice, easy way to do integration tests, it was just like, fine, I know what I need to do next. I need to have this thing wrapped inside that thing. I don't know why that's the case. I just know that that's the way their XML works, so I'm going to match it. And in retrospect, when I got done, I think the way they represent that AST in XML is very odd. Like you said, there's times where they like omit something that's called out in the grammar, but not in their AST. And there's
Sorry, go ahead.
Yeah, and then there's also times where, like, I can't remember the exact example, but I remember as I was implementing, I actually noticed this and thought, oh, this is really weird, where there's like one case where a certain grammar structure is like surrounded by curly braces, and those curly braces are supposed to be outside of the grammar structure, the way you represent it in the AST. And then there's another one where like you're bounded by these opening and closing parentheses, but those are put on the inside of your grammar structure, the way they represent it in the AST. And so that was definitely a case where I was like, why is one written this way and one is written another way? And in order to make it work, so since my code, I'll just jump back real quick just to show a concrete example here. But see, and then drag, and then params list, right? So the way all of my functions for all of my parsers have the same basically method signature or function signature, which is I take in the tree so far, and then the remaining elements, the remaining list of tokens, right? That's all of my functions take those two arguments, and they all return a tuple of two things, which is here's the tree as of the time that I'm done parsing, and what's left after I was done parsing, and like the list of, so this is a list of tokens, and this is my AST tree as of right now, and but because of their decisions about like, oh, you match these parentheses, but they go on the outside of this grammatical structure, whereas in other cases they put them inside the grammatical structure, it ended up making some of my code, some of my functions really awkward because I actually had to nest it as two function calls and kind of match the next token on both of them, and then like glue it back together. So there was places where the fact that I was matching it exactly right from the start actually led me down kind of a poor code choice, I think. And so I would definitely, like, if I was talking to someone who was taking the class, which hopefully I am, then I would say like it's worth talking to your professor or a TA at the beginning of this project and just say, hey, I'm thinking that I want my AST to match the grammar exactly, if you want to go that direction, which I would suggest in retrospect, having looked at my implementation and Dan's implementation. I think looking forward to the next project, it's a lot easier to create your symbol table and stuff like that if you're looking at a data structure that very closely models the grammar of the language. I think that makes some of those things easier. And so if I were taking the class and I had this retrospective or this perspective that I have right now, I definitely would go to my TA or professor and say, hey, do you mind if I actually make it match this, more specifically? And along those lines, it might be helpful, Dan, for you actually to post your code, and then also we could maybe set up a link to like a gist or something where you put your XML output of the XML, which matches the grammar very specifically, or more specifically, and so if someone wanted to use that and go to their professor and say, hey, I wanted to match this instead of the XML that was provided in the chapter or in the project, I think that most professors that I took classes from would probably be like, cool, totally, that's fine. Like, if you get something wrong, you're going to find out in the next chapter anyway, the next project.
Yeah.
So, I don't know. I would.
That's kind of why I finally just said, I'm like, well, enough is enough. Like, I don't think I've lost any information here. I think I will not have too much trouble working with the next chapter with what I have. So, but yes, with any luck, mine will become the new canonical representation of the XML for this project and make it the next edition.
There's not a GitHub project. I did check. As far as I can tell, there's no GitHub project that contains all their code for the book and for the projects. Which, considering the fact that they made it all free on Nand2Tetris.org, I kind of thought that there would be somewhere. And actually, one other thing I'll mention, I forgot to mention this at the beginning. For anyone who's running on Mac, I don't know if you ran into the same issue or not, Dan, but I'm just going to share my screen one last time. And I noticed that in the zip, so my Nand2Tetris thing, it contains this projects directory. It contains this tools directory, and then that contained this text comparer. And at least in mine, I don't know if I'm just crazy or whatever, but it had the text comparer.bat, but it didn't have a text comparer.sh.
Did you make one?
Yeah, so I just wrote one. I just looked at the other sh files and then wrote one text compare.sh, because all the other ones have like matching .bat and .sh files for Windows versus Linux / Unix sorts of things, but there just wasn't one in there for text compare. So I'll make a gist and I'll link this also as well in the for our YouTube video of this, just because I'm imagining that other Mac users will run into the same thing of being like, wait, I can't use the text compare. What's going on? So
just use diff. Just use diff.
Well, diff though, it's not an exact diff, right? Like their text compare is actually comparing the structure of the XML. So for instance, if the value inside of your XML tags doesn't have spaces exactly around it, I don't think that mattered. And also, like if you had indented your XML the same way they did, that wouldn't matter. So
okay. That's cool. That is better.
So yeah, so for those reasons, I was like, oh, I would like to use their text compare because I don't want to write all that stuff again. I'm sure that what they're doing is something like writing an XML. What's that process called? Canonicalizing an XML document. So like, there's if I have this data in the XML document, this is the canonical representation is in terms of white space and everything. And I think they do that and then do a diff on it. So it is useful. It does give you a little bit more value. Like if you don't want to have to worry about spaces versus tabs and all that stuff, it'll just ignore all those things and really just compare it.
Just be one long string of characters. Shoot.
Exactly.
I'm going to go revise my XML formatter now.
Yeah, so I would definitely, I still actually left most of that stuff in my XML formatter because it made it easier to read my XML output. At least the new lines, I left the new lines in there, but I don't think I bothered handling what indentation level I was at and all that stuff I didn't do because I was like, nah, that's all right. The text compare will take care of it. So I'll post that for any Mac users that want to use it. But yeah, I think that's about all I have for this week.
Sounds good. Yeah, I don't have anything to add. I will just point out though that the pragmatic programmer once again gets the solution that actually works in the real world, that is matching the spec, whereas the guy coming from the ivory tower ends up with something that doesn't really quite make it in the real world, that is matching the desired spec. But oh well, I still had a ton of fun. Like it says, my favorite project so far.
Well, if our goals for doing Nand2Tetris are to learn and try new techniques, I would say you win this week because mine passes all the specs and that's amazing and that's pragmatic, but it's like that's not actually the purpose that I'm doing this, right? I'm supposed to be trying new ideas, and I did. You know, I learned a lot about Elixir. I had several aha moments, specifically functions that generate other functions. I had read about that so many times, and lots of programmers that I knew were like, oh, it's so amazing when you can write these higher order functions, and I was like, what does that mean? And they're like, oh, it's a function that makes another function. And I'm like, how's that useful? You're just making more of the same thing. And then it dawned on me that something that I do in object-oriented languages where my object has to encapsulate a little bit of state so that someone else can use it in a more easy way, right? Like one person's in charge of generating that object with the correct state and all the settings or whatever, but then someone else can just call it without having to provide all those settings because it got generated with those settings. And you could do the same thing with functional composition by saying oh, I'll just call some function with the options and it will create me a function that now has all the correct expectations. And that's exactly what you did with any and maybe. And so that was kind of an aha moment for me this week as far as functional programming goes. Oh, that's what functional composition does, is not just breaking down a problem, but also allowing you to, in sort of a tricky way, encapsulate state by making a more specific function, a more specific version of your function, without you having to write all the specific versions of that function. So
I think it's true. Well, hey then, look, I think we both learned something these last several weeks we've been working on this.
Yay! Also, pro tip, join study groups and make study groups because they're an awesome way to learn. And so I think we'll wrap up this week just by saying a big thanks to Dan Dorman once again, as always, for joining me and for writing awesome code and challenging my assumptions as we go through this book. And it's definitely been super beneficial to me, and I thank you very much, Dan. Any closing words from you?
Nope. I just want to, well, I guess yes, because I just followed that. No. So yes. So I want to say thanks to you, Mike, for starting this thing and sticking with it, because it has definitely been a blast. I've been learning a ton, and man, yeah, it's just been a really great time. So thanks for putting this whole thing together and keeping keeping me motivated.
Sweet. Well, we have 2 projects left. I'm sure that they will not come in the next 2 weeks because they both look a bit like they're going to be doozies. So don't expect any tight timelines from us. We're going to be just doing this on our free time. But I'm guessing that if you are taking this as part of a college course, we will be done with projects 11 and 12 by the time you are getting to those projects in your semester, because that means that we have like 11 weeks to get there. So hopefully we're done within 11 weeks, or else I will have lost all motivation and I will have given up. So with that being said, thank you everyone, and we will see you for Project 11. Night, Dan. See you next time.